Perfect. Thanks a lot. Hi, everyone. A very warm welcome to our talk about reducing emissions and environmental pollution with carbon neutral materials, which in our case is biochar or biochar-based materials. As I was just introduced, my name is Theresa. I'm representing Holcim, one of the global cement and concrete manufacturers in the world. And more specifically, I'm part of the Holcim Maker, which is the internal venture client unit of Holcim. But I will explain more about what we do in a second. But first of all, I'd just like to mention again that it's a real pleasure to be part of this conference. So first of all, thanks for having me, and also a big thank you to my colleague Venna and the team from Novocarbo, which we are partnering with and who are supplying us with the biochar, and who invited me for this event. So maybe before talking about the partnership that we are currently exploring together with Novocarbo, let me share just some very key facts about Holcim, because I assume not everyone here might be familiar with the construction industry. So as I mentioned, we are a leader in the building materials industry. We are based in Zug in Switzerland, and we are manufacturing very traditionally cement and concrete, as well as other building materials or building elements like aggregates, roofing solutions, and so on. So we have several subsidiaries and also roughly or more than 2,000 operational sites across 70 countries. So we have quite a global presence, I would say, with our business. Nevertheless, even though we are in the industry quite successfully for quite some years, I think more than 100 years already, we also know that the construction and building materials industry cannot operate and do business the way it did over all those years in the past. Because of, as you all know, the construction industry is responsible for 38% of all the global carbon emissions and more than 30% of the total waste that is produced is also coming from construction and demolition. Quite some challenges ahead, I would say. And even though the industry might be a bit late comparatively or compared to other industries, to address all those environmental challenges, we at Holcim take this quite seriously. And as you can also see from the different initiatives on the slide that we're pursuing and the different rankings and certifications we are aiming for, we try to take best action towards decarbonization and a more sustainable and environmentally friendly construction ecosystem. So today, around 1/3 of our sales is already coming from green solutions. But of course, we honestly also know that this is not enough and that we still have a very long and challenging way to go. Nevertheless, what I can tell is that we're super willing and eager to do so, and that we're also quite confident that we can achieve our quite ambitious targets of getting to net zero and being at the forefront of sustainability. And so having said that, there are basically two reasons why we believe that we can and that we are quite well positioned to becoming a pioneer in this regard within our industry. And on the one hand, we have a global operating R&D team with more than 3,000 scientists. So we have a very strong research focus, I would say. And we also managed to already file more than 1,500 patents solely in the field of green construction. But of course, this is also a number that we're constantly working to increase. So this is the one part, but on the other hand, and this is the part where I actually want to focus on, and also where my team from the Holcim Maker comes specifically into play, is that we know we cannot achieve this transition towards decarbonization entirely on our own, but that we need strong, innovative partners. And so by acknowledging that most innovation, either the groundbreaking, disruptive ones, but also the more incremental innovations, happens within the startup ecosystem, we made collaboration with startups a key priority within our organization. So this is kind of the twofold pathway which determines how we strategically try to progress towards being a more sustainable as well as more digital company. And so let me explain also what Holcim really does and how our contribution looks like to this intended strategic direction, because I think this can be super interesting for you also as like how to collaborate with startups, and this is also sets kind of the basis on how we came in contact with Novocarbo. So organizationally speaking, we are part of the digital team within Holcim. But from an operational perspective, we are basically working with our open innovation approach across all different kinds of business units and also across all different kind of topics that occur within our company. And the aim of our work is to enable the different business units internally to collaborate with startups and adopt startup solutions. And the way we're doing this, we have a very standardized fast-track venture clienting process, which then in the end hopefully enables our colleagues to become a professional venture client, as we call it. So what does this mean? The starting point for us at which we come into play is typically a problem that the business unit is facing, but unable to solve on their own, either from a capability or from a resource perspective. And at the same time, however, it should be a topic or a problem where we think there could be a promising startup out there, or there's a great likelihood of that. And in this process, or in this phase of our process, we act basically as a matchmaker, screening and evaluating the startup ecosystem, and then sequentially identifying the one best fit solution for this particular use case or problem at hand. And then in the next step, we also encourage and accompany and or guide the business unit to test out the selected startup's technology or the solution on a very small scale, but typically within real world conditions, so that we can actually verify or even falsify the expected value proposition of this technology. And by this, in the end, we want to enable everyone to take an informed decision, an informed buying decision. And if such a pilot scenario or a POC phase was a success, to adopt and roll out the solution then within the entire organization on a larger scale, but of course with limited risk because we already have the first results collected. So yeah, this is kind of how we operate, and this is also how we came into contact with Novocarbo, where I will now hand over to Venna to introduce herself as well as the company in more detail.
So I'm Venna. I'm Venna Lepel. I come from Novocarbo, and essentially what we are doing is we try to take CO2 from the atmosphere permanently. How does this go together with Holcim, the company that you just talked about? Is we try to do sustainable products from that carbon. So the way that we partner with Holcim in this case is that we really try to move with our products forward and to bring them to the most sustainable use we can find. We are a startup, so when Theresa was saying they're working with the small player, that's us. We are still a very small company. Of course, we're scaling, but we're now something like 20 people. We've been 6 people by the end of last year, so for us, this is already a pretty big scale that we're doing right now. How do we do this? Actually, what we do, we combine nature and technology. So you all know photosynthesis. Plants take up CO2 and they breathe out O2, so the C gets stored inside the plant. And we take this process, photosynthesis, and we combine it with the technology that we call PCS, pyrogenic carbon capture and storage, in order to make that C, the carbon, permanent, so that it cannot be released anymore. If you think about plants, normally they take up CO2, but after a while they will decay or they will be burned, and the CO2 will go back into the atmosphere, which is a total normal and natural process. That's just the usual carbon cycle. What we try to do is to bring in technology to take some of that carbon out of the natural carbon cycle. So there's plants that we have, natural materials that they contain the carbon from the atmosphere, and then usually they get used by an industry first. So if we talk about the stuff that we use for our process, we only focus on residues. I have to say this always quite clearly, because people then think, okay, so you need lots of land in order to grow the biomass, the same you might imagine from biogas plants. That's not what we do. We only focus on residues. So industry uses the biogenic materials before, and then we take whatever is left over. Think, for example, if you grow nuts, you will have a lot of nut shells. So the nut will be used in food production, but the nut shells are just, nobody wants them. So we can take those. Or if you have woody biomass and it's used somewhere in the production line of an industry, then we can take whatever is left over and use it. Also, in the production of wood, especially in the forestry, there are sometimes leftovers from sawmills, or even in the forest, if they do wood chips, there are some sieve leftovers that they cannot use. They are left to decay in the forest, also in Germany, which is also totally fine, but we can take those and try to make that carbon permanent. So then, now I'm here at that process where it falls down in our machine that you see here. I try to take my finger. That's our machine, our pyrolysis machine. And the really interesting thing about the pyrolysis machine is that why we try to make that carbon permanent, we actually produce regenerative energy. So the first great thing about our process is that we produce more energy that we need. And then what happens is there comes out a material called biochar, which is a solid form of, it's just carbon, it's like charcoal. So what has been CO2 up front of the process in the air is then a very easy storable product, like a solid product that we can put in a big bag or put on a truck and just ship it somewhere. Because this whole process is in the end carbon negative, we get a carbon removal certificate if we, of course, only if we get the credit right, if we do an LCA for all process, if we go into a registry. So there's a whole lot of steps involved to get that carbon credit. It's just not happening magically. But in the end, our product takes out more CO2 from the atmosphere than we need in order to produce it. And this is something that I always find really, really amazing about what I'm able to work at the moment, at this phase of my life, that actually the more we sell our product and the more we produce, the better for the planet. So it's kind of a paradigm, because we always try to reduce and to do less and less and less. But in this case, at least where we stand right now, it's good for us if a lot of people buy our products, and it's good for us if we scale, and it's good for us if we grow. So what are we doing? I brought this as kind of a proof, so that I'm not only talking about it. This is just the amounts that we took out of the atmosphere. I have to say not all of these amounts have been certified, because the carbon credit business for us only started around 2019. So we've been doing this since 2018, but it matches the biochar mass that we either produced or that we traded. And what you can actually see here is that we're trying to scale, and also scaling already in 2022, but even more in 2023. And then, of course, we aim to go on that scale, but it leaves you with a question. So what do we do with the product? It's a great product, but we still have to try and sell it in order to bring it in a sustainable use. Oh, okay. I think you may not be able to see the map, right? It's Europe. So we have 3 sites in Germany this year. We just launched a site near Lippstadt a few weeks ago, and we will launch another site in Grevesmühlen by the end of the year. Then we will move in Poland in 2023 and in Spain. So this is what we're planning for next year, which is already quite ambitious. And after that, we have sites in the pipeline. Now this is a world map. So I believe it's only white for you. But you can see here that we're actually moving then into the USA and South America. Okay, so I talked a lot about biochar. What is biochar? This is a picture, an electron microscope of biochar, and what you see, it's a very porous material. It's basically carbon and minerals, what it is, and Can somebody help me get that away? Thank you. And it has different attributes and different things that you can do with it. And what we at Novocarbo have been doing in the last years is really trying to make the best use of that material, understanding the material, trying to develop it from different biomass, and also bringing it to the best use that we can do. If you see this as this picture, if you imagine a ton of biochar equals, with our LCA and the process after we take out all process emission, a ton of our biochar equals at the moment 2.9 tons of CO2. So every ton that we put in some construction will make that product that has 1 ton of biochar in itself minus 2.9 tons of CO2 if you have the carbon credit. So what do we do with the biochar? We just heard it. We try to substitute fossil carbons in concrete. This is one of the things that we do. And this is where we work with different partners, also with Holcim. But this is not where we stop. We also do polypropylene. So this is where we're a step farther. We can actually use that biochar and bring it in polypropylene. And then that's quite easy to do. This is also where we already did a master batch last year, and where we do different collaborations with universities, because with polypropylene it's a material that can be used for so much things that's not so hard to do, whereas concrete is pretty hard to do. If you think about building materials, there's a lot of things involved. People want a lot of security, they want liability, they really want to know that this building will not collapse at some point. So altering somewhere in the construction industry for us is really hard to do. The thing that is most known, where biochar is most known and what is best researched, is actually soil amendment. So very far away from this, very far away from the materials. That's where we are in soil amendment projects, for example, in Scandinavia, where we do sponge city projects and projects for city trees and green roofs and stuff like that. Also agriculture and forestry, but this is still kind of a small market for us. We also understand that if we can actually alter materials, we believe we will have an even higher impact on how we work in our economy and how our economy works than if we only focus on soil amendments. This is why we really push forward for materials here. I'd like to explain something about this removal credit. I just said that like 1 ton of biochar is 2.9 tons of CO2. But in the end, the material that we have is actually carbon neutral. So I'd like to focus first on the right side of this chart. So the material comes with a 0 footprint. Even if you only buy the material and you use it for your whatever you try to produce, you will be able to reduce the footprint of your product. And this is where we heard a lot about today about scope 3 emissions, and this is where we can make a good impact, because we can actually alter scope 3 emissions in providing a CO2 neutral products to a manufacturer. So we substitute materials that have a high footprint there, and then the resulting emissions reductions are owned by the user. If you buy our biochar, the emission reduction, you can put that in your LCA. That's totally fine. What you cannot do, and where we have to come into place, is then also account for the carbon negative carbon credit, because this is a whole different system, and it's actually something that has to be bought aside from it. So based on an LCA, we do a carbon removal credit, and this is owned by us, by the producer of the biochar. And if people want to work with us and buy our products, they get the carbon neutral material, and if they actually then also want the carbon credit, they can buy that as well. Why do we talk about concrete? I told you there are different things that we can do, and we can have a lot of impact, but in concrete, it's actually that if you look at the global emissions, 8% of all the global emissions at the moment are caused by concrete. So it just has an enormous impact of what we do. Plus, concrete is used everywhere around the world. It's one of the most common used materials in construction. This is why we know that if we can alter something here, we can really make a difference. How does that come? I don't know whether all of you are familiar with this, but if you talk about the footprint of concrete, most of the times they only count for the process emissions of the cement. This is 50% of what is allocated to concrete, because if you actually want to make concrete, you put ground limestone and clay and kind of this rotating thing. You have a lot of heat that goes in, and out comes clinker, which you need for concrete production. This is the cement. Otherwise, all the other materials from concrete are actually not so bad. There's sand, there's water, there's some rocks. That's all fine. There's some transport emissions, yes, but the thing that's really hard to come down in emissions is just from the process, because you need that thing. You need the cement in order to do the concrete. So 50% is just from the process, and then another 40% that you can allocate to concrete comes from just the thermal emissions that you have in order to heat up the process. So 90% of all emissions from a ton of concrete is only from the cement, which makes it pretty clear that if you want to change something, you should change something about the cement in your concrete. What we can do with biochar is we can actually substitute the cement, and that's when it becomes really interesting. So we can take 10%, between 5 and 10% of the cement we can substitute with concrete. We can also substitute other conglomerates in the whole concrete system with the biochar, and we come to different measurements of what else we could do. But what's also important is we alter the way that the material works. We can make it more beneficial. For example, we can add a low conductivity, which makes it very interesting for people to detect small cracks in the concrete, because then you can put electricity through and you can actually measure it very easy, which is great. We have a limited flammability if we add biochar, and we also have an improved chemical stability. Sounds all great, but it means for somebody using the material, we actually alter the material, which is just a huge problem. So this is why we cannot do it alone, and we always need somebody to help us on this way. If we, that's my last chart before I give over to Theresa. But if we actually replace 10% of the cement by biochar, I just put down some numbers, and it's a very rough calculation I just did on with some web research. But it would equal an avoidance of 258 megatons if we only substitute 10% of the cement, and we would have a removal of 1,247 megatons of CO2, which is pretty huge. And the crazy thing, while doing this, we would always produce carbon neutral energy. So we would actually be beneficial for the whole economy. When we want to do this, we just talked to some of the regulations in Germany. They told us, okay, if you want to register this part of this special percentage of the special biochar that we would use for this project, it's like 5 to 6 years until we will get a stamp on it that you can use it in construction. As a startup, it makes it really hard for us, because no investor really wants to hear, yes, we're doing this process and maybe in 6 years we can use it. Hey, great, give us some money. So they're pretty much, it doesn't work for us. And this is why we're really, really relying and are really happy to have found a partner in Holz & Maquier, where we can do a process and a project together, which will now Theresa present to you further.
Perfect. Thanks a lot, Venna, for explaining what biochar does and can do. So maybe, can you see my...
Yes,
you can.
Perfect.
So I just remember that at the very early stage of our talks with Novocarbo, the team presented us this list or this database. And by this, we quickly realized that biochar is not simply biochar, but that it can come in so many different types with many different characteristics. So both from physical and chemical properties. So there's a real huge variety. And based on this, eventually our material specialists and our scientists in our innovation center decided or got interested in starting a pilot project fully dedicated to the exploration of different biochar products as a substance per se, so that, again, like in the end, a very informed decision can be made in regards to potential applications, like where can maybe different types of biochar can be applied. And maybe to the project setup. So we from the maker thereby again take the role of the matchmaker and project manager, and Novocarbo is in the role of supplying us with different biochar samples. And of course, they have a lot of expertise and learnings to share. Whereas on the other hand, my colleagues within Holcim are analyzing, testing, and verifying the claimed properties in the labs. And of course, also share back their insights and learnings. So this is basically the phase that is still ongoing and we're currently in. So here you can see a short timeline. We started the project in June, and it will end by the end of this year. And right now we're right in between the two milestone meetings. So we are expecting some more results to be released soon. But yeah, there's a lot of exploration and testing going on in the moment. And I don't know, I mean, you learned a little bit about biochar, and I also honestly have to admit that my colleagues from the labs probably would be much better equipped to explain you the different characteristics they're looking into. But just on a very high level, what the materials are tested for within this pilot comprises a lot of different factors, such as, for example, the air content, water demand, chemical stability, flammability, CO2 savings, and so on. And one is also the depollution capacity, which in the first phase of the pilot, the team was particularly focusing on. Because what is maybe also interesting to say is that, of course, there are many benefits biochar can provide. And some of them have already been outlined by Venna. But we can also imagine, and we also pursue different application scenarios. So besides the purpose of carbon capturing and carbon sequestration on site, we are also, for example, looking into the purpose of soil decontamination, stabilizing basically the contaminants in our quarries, for example, which is a big problem, and also water or wastewater treatment, which is another quite relevant environmental pillar that we are tackling internally across the organization. But of course, as you can see here, with all these numbers, which Novocarbo and also academic research is communicating to actually show the potential that biochar could have in terms of CO2 emissions when being used within the cement production, are quite impressive. I mean, here you can see like 260 megatons CO2 avoidance and more than 1,200 megatons CO2 removal per year. This is, of course, definitely impressive and interesting. So even though we currently are maybe at a very explorative and still early stage of familiarizing with biochar and the various potential superpowers it brings, we are definitely curious to see where the journey will lead us in the end. And yeah, we just hope that we could also spread some excitement among you for the construction industry and for such innovative, sustainable solutions. So also looking at the time, I would say like, thanks for your attention. If you have any further questions, feel free to reach out to me anytime. And otherwise, Venna is around today and tomorrow at the event. So I think she will be definitely happy to answer your questions or have some more in-depth discussions around this topic. And yeah, I hand over back to you, Venna.
So I'm very much looking forward to seeing you at my roundtable to talk about something, but even more to get together at lunch or later in the evening or tomorrow and discuss what you are doing and what we are doing, and happy to answer anything that comes up your mind. Thanks.